Hi, we're going to take a look at negative exponents today. It's really pretty easy, but it does look kind of weird at first. Alright, I've got 4 problems on the board. We're going to start with 3 to the negative 5th power. And when you work with negative exponents, it's nice to think about fractions. 3 to the negative 5th is really 3 over 1. The negative exponent means that you want to flip your fraction upside down, and then you write your exponent, and once you flip it, the exponent becomes positive. So it's 3 to the 5th power. Let's take a look at this problem below. So 2 is really 2 over 1. The negative exponent means that we're going to flip the fraction upside down. We're going to keep our exponent, and it becomes positive once we've completed the flip. C to the 8th power, C would be over 1. Again, we would flip it and keep our exponent, and it would become positive. So we're using the reciprocal. In this problem, we have a to the negative 7th power and b cubed. B cubed is in the right position. It doesn't have a negative exponent, so it doesn't have to be flipped. So if we think about this as a fraction, the only one that's in the wrong position is the a to the negative 7 power. So I'm going to keep my b cubed in the same place, and I'm going to flip my a to the negative 7 to the bottom, and then it becomes positive, and so this would be the answer. Let's take a look at a couple more problems. Let's take a look at this problem, a squared c to the negative 5th power. The a squared is in the correct place, so I can put it there and draw my fraction bar. And the c needs to be flipped. It's on the top, if you think about it, over 1. So we need to move it to the bottom. And then when I flip it to the denominator, it becomes positive. So the answer is a squared c to the 5th power. Let's take a look at this next one. The first thing that you want to notice is anything to the 0 power equals 1. So I can erase that and think about it as 1 times n to the negative 4th power, which is just n to the negative 4th. Now, I'm going to make this a fraction, and I'm going to flip it upside down, and then the 1 goes on top. Alright, this last one in this set, the x is in the wrong spot. The 16 is okay, the y is okay, because it's really like it's y to the 1st power. And the x is to the negative 6th power. This does not apply to the 16, it only applies to the x. So you could kind of think about it like this. 16 times x to the negative 6 times y to the 1st. Well, the 2 that don't have negative exponents are just fine. So I'm going to go ahead and write those on top, and then I'm going to flip the x. It's really in the numerator if you think of this over 1. So I'm going to flip it to the denominator, and then again the exponent becomes positive. Let's take a look at dividing with negative exponents. When the bases are the same, you subtract the exponents. So the exponents are 2, and then subtract, and then whatever the other exponent is, which is negative 8. And a minus minus makes a plus. So now it's really 2 plus 8. And so the answer would be 7 to the 10th power. This would flip up to the top. And when it flips, it would become positive. And that's how you would get 7 to the 10th power. I like to think about it as 7 squared is in the right place, but the 7 to the negative 8th power needs to come up on top, and once I flip it up, it becomes positive, and so then you come out with the same answer, which is 7 to the 10th power. Here, the negative 3 needs to go down in the denominator, so that's going to leave a 1 on top, and then I'm going to have 2 to the 4th times 2 to the 3rd power. And so if I combine those, that's going to be 2 to the 7th power. If you remember the rule about multiplying bases and exponents. When you multiply the same base, you add the exponents. And this fraction, the 3 is in the wrong place and the 6 is in the wrong place. So really it would look like into the 6th power over into the 3rd power, and then I would subtract. I have more n's on top, and my answer would be into the 3rd power. Let's take a look at this last problem. So my 5 is in the right spot, and the k to the 3rd power is in the right spot, but the k to the negative 8 needs to flip up to the top, and it becomes k to the 8th. And then we use our rule for multiplying bases, the same base, and that would be 5. We would add the exponents, k to the 11th power. Let's take a look at this problem. Alright, in this one I like to think about the numbers separately from the m's. So I'm going to think about the fraction 15 divided by 3, which is 5, and I'm going to write my fraction bar. This m is to the negative power, so the m on the bottom is okay, but this other one needs to flip down into the denominator, and then I would use my rule for multiplying the same bases, which would be add the exponents, and that would be m to the 9th power. Let's take a look at one more set of problems. Let's take a look at this last set of problems. This time they want you to write this fraction without the fraction bar. So this is kind of interesting the first time you do it. I can actually write it as 2 to the negative 4th power, because if I make my exponent negative, it causes it to flip and become 2 to the negative 4th power. Let's look at this one. They don't want me to write the fraction bar, so I'm going to leave my a squared. But the problem is I have a denominator, so they want me to write the answer without the denominator. So to get c to flip back up to the numerator, I have to make the exponent negative. So that was pretty easy. Let's try this last problem. Again, the m to the 6th is fine, and the n squared is fine, but I need to get rid of this p to the negative 4th power in the denominator. So to do that, I have to flip it up. It becomes positive, it goes away, and then I don't have the fraction bar. So this is the basics of working with negative exponents. Thank you for visiting my video, and check out my others online.